And reduction will only take place if oxidation is also taking place. You don't get one without the other. Because what's happening is electrons are being transferred from one atom to another one. All right. Let me try it one more time. This is going to be almost impossible without a tablet today. Oh well. Difficult challenge. I can do it. All right. So we've got a ton of examples in the I think we call it alternate notes in exam 5 materials. Let's see. Yeah, so it's in the study resources section. All right. So what is reduction? If an electron is being transferred, the electron has to go from something to something else. So I always remember it by this saying, and there are other ones. There's this one, which is oxidation is losing, reduction is gaining. The one I remember is Leo says Gur. Come on. And Leo says Gur is just losing electrons, is oxidizing, gaining electrons, reducing. Now, you would think they would call it the other way around, because if you're gaining something, why are they calling it reduction? They named it when they were talking about, they were looking at it more as losing oxygens, but you don't have to have oxygen involved in order to undergo reduction, so they've changed it. But the name is still there. So reduction is losing electrons. All right, and oxidation is gaining electrons from something. All right. Did everybody get a chance to take the quiz this morning? I see a lot of people are just now coming in. Yes? Good. All right. It didn't show up for you. Okay. There was a little bit of an error with that. Let me fix it. It shouldn't have affected most people. I noticed as I was coming to class that the quiz was set to end at, what time did I have it set to end at? Quiz 21. To end at 10:10, which is when class starts. Normally I have it end at 10:20. So I'm just going to have it end today at 5. That way, I mean, if you have another class after this one, or, I don't want you to have to take it right now because you'll miss part of the class. Actually, let's just do 11:59. All right. So if you didn't get a chance to take the quiz at all, then it's going to be open till later tonight. Yeah, it wasn't supposed to close early. That was an accident on my part. Normally I put 10:20, so that wasn't something you guys were supposed to have known. So it's not really something you could have known. That would have been kind of hard. Okay. We have to go over the redox rules. And you probably wonder, what the heck is an oxidation number? Because oxidation numbers are when things change. No, that's redox reactions. Oxidation number is the number you would theoretically assign an atom when all of the more electronegative atoms get full possession of the electrons. And I'll show you more about what that means in a second. Oh, Arib, I meant to say, what is your question? I clicked the wrong button.
Professor, isn't the oxidation is losing the electron?
Okay. Let's see. So the oxidation number is the number an electron element I wonder if I've got my volume down or something. No. Okay. Oh my gosh, did I do that? Very sorry, guys. One of those mornings. So let's see if I can select this. Come on, select. Okay, that's better. All right, sorry about that. So reduction, gaining electrons, and oxidation, losing electrons. Sorry, guys. That's good. I'm so lucky to have such a good class that you guys are paying attention and you notice that. I appreciate that. Okay, so oxidation number is the number an element would get as a charge if we assigned the electrons totally to the more electronegative atoms. All right, so that's what an oxidation number is. So it still probably seems kind of like, what? Don't they just have charges? The answer to that is yes. And then your question will be, well, why bother with this stuff? The reason is because this works in a lot of, it helps you when you're working with electrical things. So for example, if you're working with electron transfer processes or electrochemistry, then the redox reactions start really to come into play. Or if you're building I'm supposed to say building a robot. No, building a battery, then you want to know, because the whole idea of current is electrons are moving and you want to know which direction they're going. So in order to build a battery, you've got to put the right stuff in each cell. And so before you just go start putting stuff in cells, it makes sense to try to estimate what's going to happen so you can narrow down what you might put into the cell, as opposed to just like, let's try salt. All right, let's try sugar, you know, which is probably what they started with in the beginning, but hopefully that's not what they're doing anymore. All right, so let's look at the oxidation number rules. The rules are how you determine what the oxidation number of something is. Most of the time, it's whatever charge it would normally have. Not always, most of the time. And with redox, we'll be able to assign carbon a charge. Because remember, we always skipped group 4 because they could be plus or minus. Well, now we have a way with redox to assign carbon a charge in a redox reaction, at least. And the rules are in the textbook. The rules that I'm going to give you are in order of priority. In other words, you apply rule 1, before you apply rule 2, before you apply rule 3, and so forth. So the first one, does anybody need anything on the page here? Give carbon a charge with oxidation. You can assign it an oxidation number, which is a theoretical charge. And I'll show you what I mean in just a second. All right. Let me know when you're done, Hunter. All right. I'm going to switch over to the notes. Assuming I can find them. I think it's this one. Yay, I got it right. Okay. So these are the redox rules. Now, that part that says page 349, that was a totally different textbook. So ignore that. That's your textbook. This is in section 8.7, I believe is the section we're doing. So these rules that are up here now are in order of priority. So we're going to go over the rules first. So make sure you write them down or take a picture of them. And then after that, we're going to work some examples. So the first one is the oxidation state of a free element is 0. So you probably wonder, well, what is a free element? A free element is just, the normal, natural, common state of an element. The more abundant state you're going to find of an element. For example, oxygen, usually we find it as oxygen gas when it's by itself. So that would be O2 gas. If you see O2 gas, its oxidation state is 0. If you see iron metal, its oxidation state is 0. Not iron with a charge on it, just regular old neutral iron. Like if I found a bar of iron somewhere and it was pure iron, it would all be neutral. So it would get an oxidation state of 0. Plain copper, bromine in the liquid state, Br2, that's its most normal natural state. So it would get an oxidation number of 0. The next one is the oxidation state of a monatomic ion is its charge. So if you have an ion that you're looking at in your equation, let's say aluminum +3, its oxidation state is +3. You don't have to do anything to it. So the first thing you want to assign is whatever is just in its elemental state. Then you want to assign any floating ions. And then you want to keep in mind that when you add all the oxidation states together, they should equal the charge. So if I have carbon dioxide, when I add carbon and oxygen's oxidation states together, it should equal 0 because carbon dioxide is neutral. Or if I was to do sulfate and I add sulfur and oxygen's oxidation states, then I should get -2. Now when I say sulfur and oxygen, I don't mean the oxidation state for just one oxygen and one sulfur. Sulfate is SO4, 2-, so that would be sulfur plus the 4 oxygens oxidation states. And then things that are in group 1 are always +1. That's not any different than what we've already learned. So if you see something in group 1 like sodium, we would normally assign it a +1. And in this case, with oxidation, same thing. Same thing for group 2A metals. But you want to assign the group 1A metals first, and then assign group 2A metals. Now, if you don't have one of those, you just skip that. So let's say you have calcium oxide, then you would assign the calcium. And then you would have to assign the oxygen later, right? Number 5, those elements are in order. This is important to know this order so that you can figure out which ones you might have to calculate for. And I'll show you what I mean as we run through some examples. So fluorine, -1. That's what we normally give fluorine. Hydrogen, +1. That's what we normally give hydrogen. -2 for oxygen, except when it's in a peroxide. I think in your textbook it says in one instance it's a +2. But you can read through that for more information on that. Most of the time you're going to see it as -2. Occasionally, like in hydrogen peroxide, you might see it as -1. So then group 7A is -1. Notice that you assign fluorine first, but you don't assign any of the other group 7 elements until after you've assigned hydrogen and oxygen. Then you get into group 7, then you get into group 6, and then you get into group 5. Now, all of these have the normal charge we've always given them, but it's important to do them in order. So you've got to practice, 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 so you get used to the order, so that it just kind of flows, and you're like, oh yeah, this is this and this. Because it's not really hard, but when you first start, it might be a little bit difficult to remember all of the little rules. So let's go back and take a look at some examples. All right, make the screen a little bigger. All right. All right, so this is chlorine. The 2 there is, we're assuming, is a subscript, but this program, not sure how to get to be a subscript. So Cl2 is how we normally find chlorine on Earth when it's by itself. So what is its oxidation number? 0. Perfect, because it's a free element. Come on. All right, there we go. All right. Now, what about sodium ion? What's its oxidation number? +1, right. So this falls into that rule that says ions have an oxidation number equal to their charge, right? So this would be +1. What about Kf? So which one would we assign first, the potassium or the fluorine? The potassium, actually. Fluorine would be the first one if we were looking at like fluorine versus chlorine versus bromine or something like that. Fluorine would be first. But the reason potassium is first is because potassium's in group 1, and that's the first rule. So the first rule has to be assigned first. So let's go back to the I'm going to switch back to the rules real quick, and I'll kind of explain why that is. Okay. All right. Let's see. I need to move this a little bit. Okay. So here are the first rule is you assign the free elements first. Then you assign monatomic ions second. And then make sure oxidation states add up to what they're supposed to be. And then the next one, after you've done the free elements and the ions, the very first one that you assign would be group 1 metals. Then group 2 metals, and then you go with the elements under that fluorine, hydrogen, and so forth. Does anybody need a second to take a picture of the rules? So a free element is something that's in its natural state. Like oxygen we normally find on Earth as O2, right? Sure. Okay. So 7A would be things that are in group 7, or if you're doing the 1 through 18 numbering, it will be group 17. So that's the halogens, fluorine, chlorine, iodine, bromine, etc. Group 6A starts with oxygen. Right? It's got like oxygen and sulfur and stuff like that. And group 5A is things in group 5, which start with nitrogen and go down from there. All right, everybody got those? Yep, okay. Let's go back to the whiteboard. All right. So we had KF. All right. Potassium is going to be given a +1 because it's in group 1 and that's the rule. Potassium gets +1. Correct. So group 17, 16, and 15 and so forth. That is correct. All right. So once we've assigned group 1 things, in this case, it's really easy to see what fluorine is. It has to be -1 because potassium fluoride is neutral. +1, you could do the math like this. You wouldn't have to. You could do it in your head. +1 plus X equals 0. Right? Then you would subtract 1 from both sides, and then you get X equals -1. Right? So you could do it that way, or you could say in your head, I know it's neutral. The only option is is -1. So fluorine gets a -1. All right. And then let's do carbon dioxide. This one's a little harder, not much. All right. So there's not a rule in there for carbon. Carbon is one of those that can go either way. It's not always easy to just look at it and assign it, unless it's like graphite, because that's the most abundant form of carbon. So what we would do is we say, well, the oxidation number of carbon plus 2 times the oxidation number of oxygen equals 0. Right? Since we don't have a rule for carbon, we would assign oxygens first. It's not a peroxide. It's just regular carbon dioxide. So what would oxygen's oxidation number be? -2. That's correct. So then we get carbon plus 2 times -2. No, not -1. -2 equals 0. So carbon has to be +4 because 2 times -2 is -4. You'd add 4 to both sides, and then you get carbon equals +4. So in this case, carbon is +4. And what would I write down if I'm looking for the oxidation state of oxygen? Would I write down -4 or -2? -2, correct. Because when it asks what's the oxidation state of oxygen, it's asking what's the oxidation state of 1 oxygen. So 1 oxygen would be -2. Oh, Samantha, you have a question.
Yeah, my question was how can you tell whether or not
Anybody today?
it's a peroxide or not? Can you hear me?
Is Samantha talking? Can anybody else hear her? Why can't I hear anybody? Oh, okay, now all of a sudden I got my sound back. Good. All right, try again, Samantha.
What I was asking is how exactly can you identify whether or not it's a peroxide or not?
Those you generally have to know. The only one that you can really memorize is H2O2 because that's hydrogen peroxide. So that's just really common. So that's one you need to know. Otherwise, they might tell you in the question that you have like potassium peroxide or something like that, and then they would have to give you the formula for that because you wouldn't necessarily know the formula for potassium peroxide. Most of the time, in the case of a peroxide, they'll tell you it's a peroxide. It's not common for them not to tell you. The other thing that you could look at, though, is this isn't really a good way to do it, but it works. Hydrogen is always +1, usually +1. We should assign oxygen first because it's before the hydrogen rule. But if we forgot and we gave hydrogen a +1, it would work. It doesn't always work, but in this case it does. So it'll be 2 times +1 plus 2 times oxygen equals 0. Okay. So then that is 2, I keep putting in an S, 2 plus 2 oxygen equals 0. And then we have 2 oxygen equals -2. So we've subtracted 2 from both sides. And then to get oxygen by itself, we divide both sides by 2, and then we get oxygen equals -1. Trying to find the one for carbon. There's not a rule for carbon, and oxygen is before carbon. In the case of the carbon dioxide, this one you just kind of have to know it's not a peroxide. Most of the time when you run into a peroxide, they will tell you it's a peroxide because you're not at the level where you have to like memorize all the peroxides yet. So, as a matter of fact, I don't know that you'll ever, I don't know that I ever was forced to memorize all the peroxides. I have a few of them memorized, but no, because you can always look it up. So, and it's just not something common you have to do. The charges for which one? The charges for the carbon dioxide? Is that what you mean? Okay, so let's go back to the rules. Let's see, share. Oh, where was I a second ago? Okay, so that's where these rules come in, as which one am I going to assign first? So if I follow these rules, there's only one choice for oxygen. So the first rule doesn't apply because we don't have a free element. A free element would be something like O2 by itself, or aluminum metal, something like that. Now, the next one is talking about monatomic ions, which we don't have in carbon dioxide. It's not even ionic. So number 3 says they all have to equal the charge. Number 4 says we have to assign group 1 metals first. We don't have any group 1 metals. We don't have any group 2 metals. We don't have any fluorine. We don't have any hydrogen, but we do have oxygen. And the rule says unless it's a peroxide, it's -2. So that's how I knew to say that oxygen was -2. Does that make sense? Okay, yeah. So it's just following these rules. So you just have to remember the rules and the order in which they go. So let's go back to the whiteboard and see what else we can work on. All right. We will do a sulfate. All right. Monatomic means one by itself. So monatomic aluminum would be one atom of aluminum. So it's just one. Yeah, we could try that one. Before we do that one, try to do sulfate. So it would be sulfur plus 4 oxygens equals -2 because it has to equal the charge. And so then you have to decide, am I going to assign oxygen first or sulfur first? Yeah, so there are 4 oxygen. Oxygen is -2. So the oxygen is going to end up being a total of -8. So you've got sulfur plus 4 times oxygen equals -2. Sulfur plus 4 times -2 equals -2. And then sulfur equals +6. Right? This is important. This is why it's important to know the order. Because if I didn't know the order, I would have thought that since sulfur's in group 6, it's going to be -2. But sulfur is way down on the list of things, and oxygen is way high compared to sulfur. Or is higher, not way high, is higher than sulfur. So if the rule for oxygen comes first on the list, assign oxygen first. So that's why, and in this case also, you got to remember that the sulfur and the oxygen, even though sulfate is a polyatomic ion, sulfur and oxygen are covalently bound. How do you get one number out of the 2 for SmartWorks? One number out of the 2. Give me an example, Summer. I'm not sure what you're asking. Oh, okay. So the answer I would type in, if it was asking me the oxidation number of oxygen, would be -2. If it was asking for sulfur, it would be +6. But it would have to specify which one it wants as an answer. It couldn't just say, give me the oxidation number, because it has to tell you which one it wants. All right. I don't have office hours today. I got my second COVID shot yesterday, and I'm feeling kind of So, but I will have them on Monday. If it's a free element. Let me give you guys an example of like a whole equation. All right. Magnesium and water. Okay. Magnesium solid plus water liquid makes magnesium hydroxide plus, I think the other part is hydrogen. Yes, and that should be aqueous. All right. All right, and this magnesium hydroxide is aqueous. I just forgot to put that in there. All right. So looking for the ones that are free elements. We're looking for the ones that are by themselves with no charge. Now that doesn't mean they have to be monatomic. They could be diatomic, triatomic, hexatomic, right? They could have a whole bunch of them, but it has to be by itself. Correct. So magnesium and hydrogen. Right off, we can assign those as 0, because that's the very first rule, is assign the ones that are monatomic and that are free elements, right? So we've got that part. Then the next part is there are 2 different things that we could do. let's do water first, and then we'll do the magnesium hydroxide because it's not really hard. It's a little bit different. All right, so we have 2 times hydrogen plus oxygen is 0. All right. So then we have to decide, does the rule for hydrogen or oxygen come first? And that, right now, you would only know by looking at it until you have them memorized. So hydrogen comes first. It's FHO 765. All right. Can anybody think of like a mnemonic to remember FHO? You do, this doesn't make any sense, but you do feathers, have ostriches. But really, it's ostriches have feathers, so that might be confusing. There you go. For show? Yeah, because they're actually in the right order in that, so that's good. FHO, sure. All right. Cool. So it's FHO 765, right? And oxygen is above that. So it's free elements, monatomic ions, oxygen, then FHO 765. Right? So hydrogen is +1. So 2 times 1 is 2, plus the oxygen equals 0. Subtracting 2 from both sides, oxygen equals -2. Right? And you can see that most of the time, let's say you forget all of the rules. They're just gone, or they don't make any sense to you, no matter how hard you try. Lots of times, if you assign them the regular charge they would normally get, it works out. Not always, as we've seen with the sulfur, but a lot of times. It's a good guess if you have nothing else. You know what? Yes. I think I did that backwards. Okay, so it is, you guys are smarter than me today. So free element, monatomic ion, 1, 2, FHO 765. Let me write that up here. And if you're using the 1 through 18, it would be 17, 16, 15, or you could do 7, 6, 5 if you were doing the A-B system. All right. So that's how you would do that. All right, so that's basically the set of rules there in really short form. All right, so now we have magnesium hydroxide. It's aqueous. What happens to magnesium hydroxide when it's aqueous? I like that, Ari. Yeah, it's dissolved in water. So Josh is correct. It falls apart into its ions. At this point, we have a monatomic ion, which would be magnesium. So magnesium's is 2+. So let me write a couple of these in. Over here we had +1, -2, +2. All right. And now we're just looking for hydroxide. So we have 2 hydroxides. So when we add magnesium plus the 2 hydroxides, we should get 0, and we would, because magnesium is plus 2, each hydroxide's minus 1, 2 plus minus 1 plus minus 1 is 0. Magnesium hydroxide's neutral. That fits. But now we have to do hydroxide. So we get oxygen plus hydrogen equals minus 1. Hydrogen comes first. So the oxygen plus 1 equals minus 1. All right, so what is oxygen? Minus 2, good. Give me one. All right. So why is it? So it's minus 1 because hydroxide is an ionic, it's a polyatomic ion. So that's why they add up to be minus 1. So when we did the magnesium hydroxide, that all adds up to be 0. When we do the hydroxide by itself, it adds up to be minus 1. Does that make sense? Yes, okay. So then over here, we have oxygen is minus 2, and hydrogen is plus 1. Okay, so now we're just going to kind of look and see what happens to them. All right, magnesium starts out as 0 and then goes to plus 2. So does it gain or lose electrons? Did it become more positive? Did it get more negatives or lose negatives? Correct, it lost. What do you call it when it loses electrons? Oxidation. All right. Then if we look at hydrogen, it's plus 1 here and plus 1 there. Nothing happened. Oxygen is minus 2 there and minus 2 there. Nothing happened. And then we have hydrogen by itself. And you may be like, what? Because how do I have hydrogen twice? If that's the case, you're still going to go back to the left-hand side and then compare it to the second time, right? So the first hydrogen right here, nothing happened. The second one, it went from plus 1 to 0. So what happened there? Gain or lose? It was positive. Correct. It gained because it became less positive. Right? So that was reduced. All right. We'll continue with this on Monday. So I can show you how to balance half reactions and do some more examples like this. I do have an alternate lecture that should be pretty good for this. Some of the stuff in the alternate lecture doesn't pertain to what we're learning, but a lot of it does. So it's a, I don't know how good it is, but it's a lecture by me on redox. So if that's helpful. Correct. Nothing's due tonight. It's due on the 29th. Well, the only thing that is due tonight would be the adaptives if you were going back and redoing something that had been missed. That's all. You're welcome. All right, and I will see you guys on, yes, they are on D2L. Go to D2L. Exam 5